we're going to do a number of problems where we're working with the heat in physical processes. Now there's two basic types that we're going to encounter. This is of the first type. There's a temperature change occurring. Another type that we'll see later is heat involved in a phase change. And we calculate the heat involved in the process differently depending on whether it's a temperature change or a phase change. Now here in a temperature change, the heat is equal to mass times the specific heat times delta T. I want to make a couple important notes. First, take note of whether the question is asking you to calculate the heat in terms of joules or calories. Also, you want to take note of the phase of water. The heat capacity of water varies depending on the phase, so you want to make note of whether it's a solid, liquid, or gas. In this case, our water is liquid water. Now we're going to work through this problem. It is a temperature change problem, so the heat is going to be mass times specific heat times delta T. Delta T is, as we see here, TF minus TI. F is final, I is initial. So TF minus TI is 19.8 minus 10.5. So we have a delta T of 9.3 degrees C. I often find it helpful to include a little quick diagram here to remind myself what's happening with the temperature. C is a specific heat. The specific heat varies from substance to substance, or in other words, is characteristic of a substance. Not only do the different substances have different values of specific heat, but as we mentioned previously, different phases of the same substance can have a different specific heat. We look up the value for the specific heat of liquid water in our equation sheet, and we see there's two values. There's a value for calories per gram degree C, and there's a value for joules per gram degree C. Since we want our answer expressed in joules, we're going to use the value for specific heat in terms of joules. All right, so finally we can come down to answering the question. Heat is equal to mass times specific heat times delta T. And we can check, but we see that our units cancel. And we're left with units of joules, and we can get our final answer. Okay, we went through a lot, but essentially a solution to this problem, a heat problem with a temperature change, is mass times specific heat times delta T. Mass times specific heat times delta T.